Continuing with number 33, I'm going to go to part B now. Okay, so we'll come down here. For part B, we have another nonlinear inequality. We know it's nonlinear because x is raised to a higher power than 1. Okay, so first thing I want to do is I am going to try and factor, but I need, because it's an inequality, I need to basically pretend that that's an equal sign. So I'm going to rewrite this, and also I'm going to move the 8 over to the left by subtracting from both sides in the same step. So I'll write this as x to the 4th minus 2x squared minus 8. And again, I'm pretending that it's an equation for now because I know I'll be doing test points at the end. So equals 0, okay? And now I want to look at factoring this. If you recognize that this is a trinomial with a power of 4, 2, and 0, and it can be factored kind of like quadratics, then I would suggest you go ahead and jump to that. I am going to give you kind of an in-between step here with some variable substitution to make this look a little bit better. So what I'm going to do is I'm going to say let a equal x squared, because if a is equal to x squared, if I rewrite this equation in terms of a, x to the 4th is x squared squared, so that's the same thing as a squared minus 2 times, and remember we're defining a as x squared, so that's minus 2a minus 8 equals 0, okay? And then we can factor this as a minus 4 times a plus 2, okay? Now, at this point, I'm going to go back to being in terms of x, so that is x squared minus 4 times x squared plus 2 equals 0. Okay, now, some of you that are a little more familiar with factoring could probably jump straight from this first step to this last one without the variable substitution, and that is no problem at all. If I were doing that myself, I probably would do that, but if it gets a little fuzzy, then go ahead and use a variable substitution to make it look more familiar, okay? All right, then from here, x squared minus 4 can be factored further, so that's x plus 2 times x minus 2. X squared plus 2 cannot be factored anymore with real numbers. We are not dealing with non-real numbers in calculus, okay? So we leave it like this, and then using our zero product rule, we get that x equals negative 2, positive 2, and if I set this equal to 0, I'd have plus or minus root 2i. We are, like I said, we are not dealing with imaginary numbers, so this factor does not matter, okay? It does not give us a new solution. So our solutions are x equals negative 2 and positive 2, but remember, this is with the false equal sign here. Okay, so we're going to do test points on a number line. Okay, and going back to our inequality, this was originally a greater than or equal to sign. I have not done anything like multiplying or dividing or square roots or anything like that, so really I can go back and pretend that this is a greater than or equal to symbol. Okay, and I'm doing test points around negative and positive 2. So to the left of negative 2, this factor is negative, this factor is negative, this factor is going to be positive no matter what, so I can pretty much just ignore it. Negative times negative is positive. A positive number is greater than or equal to 0, so anything to the left of negative 2 is part of our solution. In between negative 2 and positive 2, this first factor would change to a positive, but this would still be negative. Positive times negative is negative. That is not part of our solution. And then again, to the right of 2, we have a positive here, a positive here. Positive times positive is positive. That is greater than or equal to 0, so that is part of our solution. Okay, now let's check and see about the actual values here. If we plug in negative 2, we would have 0 times something equals 0. That is true. So negative 2 is part of the solution. Same thing with positive 2. In general, if you have the or equal to part of an inequality, then your solution points are part of the final solution. I would be very, very careful with just assuming, though, because if you have a variable in the denominator, like just for example, if we had 3 over x somewhere, and x equals 0 was one of those critical points, x equals 0 would have to have an open circle because 0 gives us an undefined number. We can't divide by 0, okay? So That's kind of the exception. But other than that, if you have the or equal to part, you're always going to use closed circles. Okay. So then graphically, we know that these two regions are a solution. So in inequality form, we can write from negative infinity to negative 2, that one is closed, union, closed, 2 to positive infinity. Okay, so here's our graphical solution and in inequality form. Okay, and then for the last one, part C, I'll come over here. For this one, you could expand, like you could actually do x squared plus 1 and square it. You'd have x to the fourth plus 2x squared plus 1, and then you could distribute the negative 7 here, and we could combine all the like terms and then try and factor from that. But the fact that it's written like this is really a hint to us of a faster way to factor. Okay, and so because we have some expression squared, and then some expression to the first, and then a constant, I'm going to think about that the same way I did this last one, and I'm going to define a new variable. Okay, so for this one, I'm going to say, let A equal the quantity x squared plus 1. Because now, when I rewrite this expression in terms of A, I get A squared minus 7A plus 10. And again, I'm just going to pretend it's an equal sign for now. Okay, so A squared minus 7A plus 10 is equal to 0. This is something that looks familiar to me, and I can factor it as A squared, oh, sorry, not A squared, A minus 5 times A minus 2. Okay, now going back into terms of x, because A is kind of like our arbitrary working variable. Excuse me. Okay, so I can't leave things in terms of A. So going back, I have x squared plus 1 minus 5 times x squared plus 1 minus 2 equals 0. Okay, I'm going to move horizontally here. So that's x, now this is x squared minus 4. I'm going to go ahead and factor that. X plus 2 times x minus 2. This one is x squared minus 1, which again is difference of squares, so x plus 1, x minus 1 equals 0. Okay, so my 4 solution points, or my critical points here, are negative 2, positive 2, negative 1, and positive 1. We're going to do test points on the number line around those. I think you can figure that part out. Check with the solution if you need to. Let me know if you still have questions on that. So I'm going to put ... math and let you finish that. Okay, last one I want to do here is number 59. This is, both sides are linear on this inequality, but they both have absolute value bars. So I'm going to show you 2 ways to solve that. Let me see if I can drag this down. Nope. That's all right. I'll just rewrite it. Okay, so way number 1 is I can write this as 2 inequalities, joint inequalities. I can write this taking absolute value, because remember, when we have absolute value bars around something, we can take them off as long as we have a plus and a minus. Okay, so I can write this as x minus 1 is less than 2 times the quantity x minus 3. So here I took the absolute value bars off of both sides. Now I need to write another one where I have where I've changed the sign. Now I only need to change the sign of one side. Oh, this is getting longer than I wanted, but that's okay. Pause on that. If we have this less than, greater than, it doesn't really matter what symbol's in the middle. But if we have something like this, we have 4, we'll just pretend it's an equal sign. We have 4 different possibilities. We have A equals B, the opposite of A is equal to B, A is equal to the opposite of B, or the opposite of A is equal to the opposite of B. What I want you to notice about this, though, is that these 2 are exactly the same, and these 2 are exactly the same, so we don't need to write the plus or minus for both sets of absolute value bars, only one set. Okay, so back over to this one, and actually I'm going to move this over. So x minus 1, oh, and because this is a nonlinear inequality, I'm just going to ignore that inequality and make it an equal sign, and then we'll go back and do test points anyway. Okay, so x minus 1 equals 2 times x minus 3, and then I just need to put a negative on either side. It doesn't matter. I'm going to do it on the right. X minus 1 is equal to the opposite of 2 times x minus 3. Okay, so now, oh, I should move that over though. Now I have two different equations to solve. Okay, so this would be 2x minus 6, moving the x over, or subtracting x from both sides, adding 6 to both sides. I get 5 equals x on that side. Over here, we've got negative 2x plus 6, so 3x, adding 1 to both sides, excuse me, is 7. So x equals 7/3. Okay, so these two numbers are the things that I need to do test points around. Okay, so 7/3 is a little bit more than 2, less than 3, so that goes on the left. Okay, and so we're going to do test points around these with the original inequality. Okay, so if x is to the left of 7/3, now here we might need to actually plug in numbers, but so let's try 0. Okay, so if x is to the left of 7/3, like 0, we would have absolute value of 0 minus 1 is positive 1, less than 2 times absolute value of 0 minus 3 is positive 3. Is 1 less than 6? Yes, it is. Okay. In between 7/3 and 5, remember this is a little bit bigger than 2, so let's just try 3. Absolute value of 3 minus 1 is 2. I'm plugging into the original statement. Less than 2 times absolute value of 3 minus 3, so 3 minus 3 is 0. Okay, is 2 less than 0? No, it is not. All right, and then to the right of 5, so let's try 6. Absolute value of 6 minus 1 would be absolute value of 5. Less than 2 times, and then 6 minus 3 is 3. Is 5 less than 6? Yes, it is. Okay, so our solution is this. All right, and you can write that in interval form as well. Okay, but I want to show you the other way to solve this, and I believe this is what your book will suggest. If you have absolute value bars on both sides, absolute value means that something on the inside could be positive or negative, but we know that if something is squared, then it is always positive. So what they're going to suggest is square both sides. And so I'm going to do that. Oops, except I need to square that. Don't forget to square that 2 as well. Oh, darn it. There we go. So coming down here, and I don't need absolute value bars anymore because anything squared is positive. So x squared minus 2x plus 1, and again I'm using an equal sign for now, equals 4 times x squared minus 6x plus 9, okay, which is distributing the 4x squared minus 24x plus 36, okay. Now I have just a quadratic equation. You know how to solve from here. When you get to your solution points, you still need to do test points around those on the number line, but this is just another way to do this without writing two separate equations. Now, which way you choose, which way you prefer is up to you. I think this first way is easier because I don't have to deal with quite as big numbers, but both of them will work, okay? So if I think you can finish this, but if you have any questions, let me know.